My name's Addison London, and this is my Capstone project. So, for the body data, first thing I'm going to do is obviously install some packages. I should have done that already so that I didn't have to do this. And then I'm going to load these packages into my Faucet Cloud. So, right here, what this is doing is just predicting loading in my data. I need to load in the body fat data, which I was given by you. And so, what I'm trying to do with this first body fat is to predict what I'm trying to do with the body data, body measurements is to predict body fat. So body fat's a continuous variable. So I'm deciding to use a linear regression model and a decision tree model. So first and foremost, load the data in, and I'm just added this a little extra. I wanted to get some data just in the beginning to see what all's on the actual Excel file. So I added that and then a summary just to give me some numbers just for it's not needed right now, but for other projects, other things, it could be needed. Um, First thing I want to do is split things into training and testing data, but I switched up the order a little bit when I was typing this out. I forgot to put the seed afterwards, but set seed so that I can continue to use this for other like if I wanted to change numbers and everything, I need to use the set seed in order to ensure that the data is reusable. And then I'm going to use this training index to split the data up 70%, 30%. So that's what I'm doing here is just splitting the data. And then right here is when I start to build my linear regression model. So this right here, body fat with I'm not really sure. I don't remember what that symbol is called, but just that with the decimal, the period means I'm including all the variables to predict the body fat. And then I just wanted a little summary of the model that I just built, the linear regression model. And then I'm going to um, use a predictions function just for the future. I'm going to need it in my, I did that so that I could use it in my, when I like check to see how accurate the stuff was. So then we go into the decision tree model, and this is different somewhat, but it's not at the same time because I'm once again using every single variable to predict body fat, and then use ANOVA here because the body fat is a continuous variable. It's not like it's a percentage, it's a number. It's not yes or no type of thing. Like we'll see later, but run this at the model in stone, and then um, get a little plot going just because I'm a visual person. So I think this helps to see things. And then that's whenever we go into build this predictions model again so that we can, um, excuse me, so we can test our accuracy. So that's where I go into the accuracy right here, evaluating it and stuff. I decided to use RMSE to measure specifically the average prediction error, and then R2, which I'll go back and run those in a minute, but R squared, R2, whatever. Um, Use that to see how much kind of variation is between kind of explained by the model and everything. And then that just displays the answer after running that. So like, let's go ahead and do that. So I'll use this, run that, and then it tells me the number. So I don't really know. There's a little thing right here that's in my way that I can't see what the number is down there. But just get the results, see how accurate it is. So like the RMSE, obviously, just the prediction error is around 2.28%, I guess, 2.28. And then R squared, just seeing that number is a little bit different. So let's run the decision tree, blah, blah, blah. So obviously they're, I mean, about the same number, but then I wanted to run correlation because that's what these two are is linear regression model correlation and then decision tree correlation. I wanted to see just how closely the predicted variables that are what I ran these predictions for. These models made this. I wanted to see just how they were, how close they were to the actual value. So develop these. And then I didn't put specific code to show that actual result, which I can add that right now. Hold on. We can add that in and then run that. And it's, 0.95 away from the original. The predicted is away from the actual value. But so, not too terrible. But, and then right here, I kind of added this in last minute. I wasn't going to do anything like this, but when I was looking at the numbers, I couldn't really see it well in my head. So created this with the help of AI to see exactly this little table that shows the number in it, so I can show which one's lower, which one's higher, and everything. And then we go into the loan applications, which this one's different. I can do all this again, but this one's different. Whereas the one earlier was continuous. This one's more categorical because it's loan data. We're using loan result as our predictor. Like that's what we're trying to get. Um, and that's either yes or no. Like, was it approved? Was it not? So that's where I kind of struggle with this one a little bit because it is so different. So I initially tried to do the same models as before because I knew what I was doing. So like I tried to do the linear regression model and the decision tree model, but the linear regression doesn't work in this because it's not it's not a continuous variable, it's a categorical. So same thing here, load in my data, load in my Excel sheet, and then just again, I wanted to see all these numbers, get those in. And then the biggest thing in here is that since it's categorical, I struggled a little bit to start. So I had to like Google what I was doing wrong and everything. And that's where I found like do this, change it from a categorical number to be treated as a factor variable so that it like truly works. And then once again, I set the seed. And I found that once I set the what's it called, the result as a factor instead of it being categorical, that's whenever my code finally worked. And so I was like, okay, that makes sense. So then here what I'm doing is just counting the number of rows in the data and then that helps with training the data, splitting it in between training and testing 70-30%. So that's what all this is, splitting the data, labeling it as either training or testing, just like before. And then you get to this is where it's different. I did the logistic regression model, which I don't feel like I'm as confident with because there's more stuff that like goes into it. In my opinion, I don't know if there truly is, but I don't know. It just feels like there was. So this one's needed over the one earlier because this is a categorical data, categorical variable and everything. So right here, I'm developing the model using all the variables to that impact the loan result. I'm not specifically picking certain things. And then I need to use the training data here. And then training data is used for building the model. Testing data is used for predicting the model. I don't know if I already said that. So then family's binomial. And then I'm going to predict I need to do probability first. Hold on. And then I need to predict it. So right here, I mean, I didn't, this is like the probabilities. I didn't really get this part at first, but I need to just pick probabilities of the thresholds, 0.5. I feel like that was a good number. And then 1 and 0, obviously. And then the actual changes it back from the factor that I changed it earlier to what it actually is. So these, obviously, I'm putting all these things in, but it's not showing me anything down here. It's not showing me any answers or anything. It's just putting it over here, right here. But in the end, whenever I run the table, it'll do like earlier and show and I don't know how to explain this. So these parts right here, I'm not wanting to see anything from them. I'm using those to determine the accuracy. And then I'm using the accuracy to build the tables. So right here, I'm building the decision tree just like before. Method is class this time, which is different than earlier because it's not a continuous variable. It's categorical, so I have to use class classification, whatever. And then predicting the class again, same as before, test data because I'm predicting class because it's categorical. Changing once again from a factor to a numerical value, to back to the changing from factor, yes, back to the original value. And then right here, I'm running the accuracy on the logistic model. And then I'm running the accuracy on the tree, the decision tree. The actual right here is coming from above where it changes it back to the actual thing. And then put those in, and then it gives me the actual accuracy, which pretty accurate. And then the table shows me how many were actual compared to predicted on both. So overall, I think it's pretty accurate. I think my favorite thing that I did in my code was the plot to be able to see these things because it helps me see. And then this table here confuses me a little bit, so I like the um, table above more because table from body data because it just is easier to see. Where's it's easier for me to see those numbers whenever it looks like that. And they're like both comparing instead of like that, and they're in two different ones, which I guess is kind of my own fault for not building the code the same way so that the tables are the same. But I mean, different. I think it's a good example to show how different like techniques can be used for different data. Because like for the body data, I had to use the linear regression model, but then when it comes to the loan data, I couldn't use that. So it's just a matter of knowing what you're doing, like knowing there's multiple techniques that can be used for different types of data, continuous or categorical, or I mean anything else like that. And then I don't know. I think this is definitely difficult, but it was good for me because it made me sit down and made me think about this stuff, made me work to um here, I guess I could move myself so you could see the plot I built, but yeah,